In this example, when I'm adding rational expressions, or in this case subtracting, I do need to check for a common denominator. And I don't have a common denominator, but I have an additive inverse, a set of additive inverses. Let's look up here. 2w minus 3 and 3 minus 2w. Writing this slightly differently, so to make it clear what I have, I'm going to put this negative 2w in the front plus 3. 2w and negative 2w, those are additive inverses. Negative 3 and 3 are additive inverses. So I have a set of additive inverses. And I'm just writing it this way over here to make it obvious that these are additive inverses. Remember that when you have additive inverses in the denominator, you multiply one of the rational expressions, both the numerator and the denominator, by -1. That's going to give you a common denominator. Okay, I'm multiplying the numerator by -1 and the denominator by -1. Come down here and I have the first rational expression is going to be unchanged. Minus, so the second one, w squared times -1 is going to give me negative w squared. Negative 12 times -1 is going to give me a positive 12 in the denominator. -1 times 3 is -3. Negative 2w times -1 is plus 2w. If you look at this, it is the same as this. Let's just rewrite it again, clarifying what we actually have, our common denominators. Okay, I'm rewriting this all the same, except in the bottom, I'm going to reverse the order of the two terms to give 2w minus 3 so that I'm sure that I have a common denominator. Now I just go ahead and add all this up. So I'm subtracting. That's the same as adding the opposite of each of these terms. So I'm going to rewrite this as adding. Negative and a negative would give me a positive w squared. Negative and a positive would give me minus 12. All over 2w minus 3. Okay, simplifying. I have w squared and w squared. I have two of those terms, so that's 2w squared, plus 5w minus 12, all over common denominator of 2w minus 3. Okay, now, we could stop here, but we wouldn't have it in simplest form. For simplest form, I'm going to try to factor this and see if I have a common factor. But instead of just trying all different possibilities, what I want to think about is what I need. And what I need is to have 2w squared plus 5w minus 12 to factor out so that one of the factors is 2w minus 3. If that doesn't work out, it's not even worth factoring because I can't simplify. So if I can't find a factor up here that is 2w minus 3, I'm not even going to bother finishing the factoring. So if, given that one of the factors I need to be this, I have to try possibility over here and then see if it works out. Well, I know I've got 2w squared as the first term, and I've got a 2w here, so I have to have a w squared here, w here. The other thing I know is that I have a negative sign right here, and I need a negative and a positive. Okay, factors of 12. Well, of course I have 1 and 12, I have 2 and 6, and I also have 3 and 4. So if this is a negative 3, the only factor that would work over here would be 4. And now I need to check this to make sure it actually does work. Okay, so this is, I know that this is 2w squared, first terms. So that gives me 2w squared. 2w times 4 is 8w minus 3w. So I have 8w outer terms, negative 3w inner terms. 8w minus 3w is 5w. Last terms, negative 3 times 4 is negative 12. And this does check out. So this is the correct factorization, which means I can simplify. So now I've factored this numerator out to this. 2w minus 3, w plus 4 over 2w minus 3. Common factor cancels out, which leaves me w plus 4. Okay, so this one was slightly more complicated because the common denominator wasn't there for us already. But I did have the additive inverse, which meant that I could just multiply either one of the rational expressions by -1 over -1. That ended up giving me a common denominator, and I added and simplified to find this trinomial. This trinomial factored into 2w minus 3 times w plus 4, so I was able to cancel out a common factor. Okay, that finishes out this lesson for Educator.com. Thanks for visiting.